Welcome to Chemistry with Schmidt. All right, so we're looking at bell work for day 2 on 11 February, and we have a couple questions here. How many atoms are in the following? And so A says 26.982 grams of aluminum. You want to know how many atoms are in that mass. So what you do is you go to your periodic table, and what you see is the molar mass of aluminum is indeed 26.982 grams. And that tells you the mass of exactly 1 mole of atoms. So your answer to this question is 1 mole. But let's also remember that 1 mole, so the answer is 1 mole. But 1 mole is also, it's true that it's equal, but it's also 6.02 times 10 to the 23rd atoms of aluminum. And if you look at part B, 18.998 grams of fluorine, we're going to see that, go to our periodic table, you see 18.998, and that value expressed in grams is exactly 1 mole of fluorine atoms. So the answer is very similar to the last one, except for it's going to be a fluorine atom. So 1 mole, or 6.02 times 10 to the 23rd atoms of fluorine. So this is the concept. Whatever mass you see there expressed on the periodic table represents 1 mole of atoms, or 6.02 times 10 to the 23rd atoms. It's a very simple concept, but the one that you need to know. And then the second question says, what is the mass of 1 mole of the following? This is kind of working backwards from part 1. So on copper, where are we going to find the mass of 1 mole of copper? You guessed it, the periodic table. So we go to our periodic table, we find copper, and we see that it says 63.546. So our answer is going to be 63.546. And what is the unit of mass? It's very important that we make sure we express our answers with the correct unit. And the unit of mass is grams. Okay, and we can put copper there if we want. So for strontium, and I'm getting a little message. That is okay. All right. For strontium, what is the mass of 1 mole of strontium? Once again, go to your periodic table. You see 87.62. So our answer is going to be 87.62 grams of strontium. All right, and then on chlorine, go to the periodic table once again, and we see that it says 35.453, and we simply just record that value. So this tells us the mass of 1 mole of chlorine. All right, so how many atoms is that? 6.02 times 10 to the 23rd, or what we call Avogadro's number. Okay, moving on to your worksheet for today. I'm going to go over 2 problems with you, and then I'm going to leave you with the rest of them. And so the first one we have is ammonium fluoride. And what we have there to first figure out is this ionic, molecular, and acid? And this is very, very easy to tell because we don't see any prefixes. We don't see it say acid. We see nothing. And so we know we should be able to tell this is ionic. And it's definitely not a type 2, although that's not an important thing to identify now. So ammonium is NH4, 1 plus, and fluoride is 1 minus, which gives us NH4F. Now all you have to do to get the molar mass of that is to break ammonium fluoride into its individual components. It is made up of nitrogen, hydrogen, and fluorine. So you just need to ask yourself, how many of each of those atoms do we have in NH4F? So we should see that we have 1. And if you're looking at hydrogen, you see that it says 4. So we have 4 hydrogen. Oops. And then we have 1 fluorine. And you're multiplying those values by the mass of 1 mole. And if you remember from part 2 in our bell work, you can determine the mass of 1 mole by simply going to your periodic table. So when you go to your periodic table and you look up nitrogen, which I'm going to have you do on your periodic table, you should see that it is 14.007. And you should see that hydrogen is 1.0079. And this is actually grams per mole. Grams per mole. And that fluorine is 18.998 grams per mole. And so you just multiply those things out. And 4 times 1.0079 is 4.0316, and these are grams per mole, and then this is 18.998 grams per mole. All right, and so add all those up, and you're going to get the mass of 1 mole of ammonium fluoride. So what you simply do, just plug those in your calculator. And you should get 37.0366 grams per mole of NH4F. So this is our answer. So break everything apart into its individual atoms, count the number of atoms that you have, and then just simply multiply by the mass of 1 mole, which you find on your periodic table. Okay, we'll go to number 2. Again, this is an ionic. It's a type 2 ionic. We can see that we know the charge of cobalt. We must look at charges. So we have cobalt 2+, we have carbonate, which is CO3 2-. Sum of the charges equals 0, so you get CO, CO3, and that's it. So just now break those into their individual parts. And we can do that by counting. So we have cobalt, we have carbon, and we have oxygen. So we have 1 of those, we have 1 carbon, and we have 3 oxygen. Now you're going to multiply by the mass of each of those elements. So you find cobalt on your periodic table, it is going to be 58.933 grams per mole. Carbon is 12.011 grams per mole, and then oxygen is 15.999 grams per mole. And so simply multiply all those out. You just happen to be gifted in multiplying by 1. So you'll see that I do those really quickly. And hopefully you become as gifted as I am. And here you should get 47.997 grams per mole. So the next step is to simply add those up. All right, and there's our answer for number 2. And that tells us the mass of 1 mole of cobalt 2 carbonate formula units. So it means we would have 6.02 times 10 to the 23rd of this compound. Okay, well, thank you for watching. I hope this helps. And I want you to go through problems 1 through 10 today. Thank you very, very much.